Hello. Uh, Previous day we was discussing about the emission scenarios and the present condition over the global. And now today I'm going to take class on engine emissions. What are the basics of engine emission? How emission pollutants are emits from an engine. So that is most important thing. So engine emission means which converts fuel or chemical energy to the mechanical energy, and this has been done by some combustion processes. We know that in petrol engine there are some different combustion process, and in diesel engine there is some different combustion process. So all the cycles are following their own combustion process. Okay. Now I'm telling about the exhaust. How exhaust gases are comes. It is basically engine emissions are classified into two types of engine emissions. One is engine exhaust emission, and another is non-exhaust emissions. So what are the exhaust emission? Exhaust emissions means that is the after combustible product, means when we gain an energy from an petrol engine or diesel engine, we are burning the air fuel mixture with their appropriate ratios and getting power from that. And what are the percentage of getting power from a fuel? That is only 20 to 25% power of a fuel or energy of a fuel are converted into the power or brake power. And the major losses of that gases, the power is the exhaust gas temperature losses. That is almost 40% losses. Now the exhaust emissions means the after combustion, the combustion gases are thrown by the engine and it goes to the environment. So if we increase the concentration of that pollutants, that means we have to compromise with our environment or nature, or we have to compromise with our next generation. So it is very important to follow the norms of an engine and always try to improve that, try to improve some mechanical devices or some electronic devices to reduce that emission constituent. Now the exhaust emission means it emits hydrocarbons, oxides of carbons like carbon monoxide and carbon dioxide. Both are harmful, but carbon monoxide is much more harmful than the carbon dioxide. And a vehicle or after combustion, the carbon monoxide are emits from an engine. It is the major constituents um, uh, of a engine pollutants. And oxides of nitrogen, that means NO2, N2O, so NO. So the oxides of nitrogen are also very important parameter. We know that BS4 is totally emphasized on the NOx emissions. So they in BS4 we are implemented selective catalytic reduction, exhaust gas recirculation to reduce the NOx emissions. And one more thing, when you reduce the NOx emissions means you have to drop the engine peak combustion temperature. That means you have to compromise with your engine performance or engine output power. Okay, so you are not getting a maximum or peak output power of an engine because of NOx reduction. And another is oxides of sulfur, means SO2 or something like that. Oxides of sulfur is also the a major constituents, and these four constituents are emits from both spark ignition engine and compression ignition engine. Okay, spark ignition engine means you know that SI engine or petrol engine, and CI engine means compression ignition, that is diesel engine. Okay, and another two constituents that is available only for diesel, only after diesel combustion, that is particulates and for shoot particulates matters like 2.5 pm, 10 pm, like that, and shoot or smoke, that is only comes from the diesel engine or CI engine. You know that the in diesel engine there are using some filters after the combustion chamber or after the combustion for purify the airs, and that filter or paper filtering filters are arresting the soot particles or particulate matters, and you have to change these filters after a certain period of time or certain kilometers of of a vehicle. Now these four and two for extra CI engine. These are the major constituents for constituents of combustion process, combustion process pollutants, and these are the emits after the combustion of an engine. Now the non-exhaust emission. Non-exhaust emissions means there is no exhaust. The emission has not formed after the combustion or power production. That means that fuel doesn't take place any combustion process or the power generation process. That is totally wastage fuel. And how this is how this can be classified? This is the basically three types of non-exhaust emissions. One is from fuel tank, another is from carburetor, another and third one is crankcase. That means fuel tank. When your fuel tank is getting heat by surrounding environment, so it can reach their evaporation or the evaporation temperatures. So they are evaporating at that time. So these evaporating fuels are totally reached hydrocarbons. So that means it is also a major source of hydrocarbon emissions. That means unburnt hydrocarbon. That is also most dangerous. Unburnt hydrocarbon particles will be generated from the non-exhaust emission process. In fuel tank, there are huge amount of fuels are stored there, so the evaporation probability is also increased for fuel tank. And carburetor also, you know that the function of carburetor, the carburetor means where in case of petrol engine the carburetor is used. In diesel engine there is no carburetor. In petrol engine, when air fuel mixture mixed before the engine, the mechanical device is known as the carburetor. Is maintain the air fuel ratio always, and also providing the appropriate air fuel ratio. Okay, so what is the appropriate air fuel ratio? That is 14.7 is to 1. That is stoichiometric ratio. Sometimes rich mixture, sometimes lean mixture, sometimes stoichiometric mixture. So all these ratios are controlling by the carburetor. and crankcase ventilation. Here I can show you a picture. This is combustion chamber. Okay, I'm drawing such like that. So this is combustion chamber. This is piston head, and this is the piston ring, which is surrounding like that. Okay, so this is the piston. This is piston head. This is piston head. These are the piston rings, and these are the wall, cylinder wall, and this is the combustion chamber. Okay, now you can see there are there are 1, 2, 3, 4, 5. Okay, so these are the some sections, means the gaps between what, cylinder wall, piston and piston ring. There is some gap. So this gap has to be provided because of the thermal expansion of the piston head, piston ring, or the cylinder wall. So there has some minimum gaps between this piston ring, piston head, and the cylinder wall. So these gaps or these areas or these volumes are known as the crevice volume. So it is very important to the, yeah, it plays very important role to the crankcase ventilation or positive crankcase ventilation system. So this positive crankcase ventilation means the gases passing through this crevice volume. This is crevice volume. So this is the crevice volume. So when the air fuel mixtures or the fuel mixtures are coming to the combustion chamber, and during the compression stroke, the piston is moving toward the TDC. The piston is moving toward the TDC. So the fresh air fuel mixtures are getting compressed by the piston, and after the during the compression, some percentage of air fuel mixtures are going to the crevice volume, and during the expansion stroke, means expansion means that is suction, compression, power, and power or expansion and exhaust. So this is the compression process. The in that compression process, the gas unburned or fresh gases are going to the crankcase, and during the expansion stroke means when the piston is moving to a during the expansion stroke, the uh, the gases of the crankcase are again going to the combustion chamber. Means there is some there is this unburnt hydrocarbon gases are mixed with burn gas or un fresh plus burn. These fresh charges are now mixed with the burn gases, and the exhaust process in that exhaust process these fresh gases are come out from the engine and goes to the environment, and it contains high unburned hydrocarbon that is also very harmful for human body and also environment. So crevice volume is taking a big role of crankcase ventilation or crankcase emission. Okay, so this is the ring gap between the ring. So these are the basics of engine emissions. How the engine, what are the types of engine emissions and some basics of engine emissions. Now you can see the graph. There is two axes. First x-axis is amount of emissions in exhaust flow, and second is fuel air equivalence ratio. Okay, so you can see that if we increase the equivalence ratio, the hydrocarbon emissions are increased, and if we increase the fuel air equivalence ratio, the carbon monoxide is also increased, and in case of NOx, after the stoichiometric ratio, the in the rich mixture, the NOx emission is reduced. So what is equivalence ratio? Equivalence ratio means the ratio of exact air fuel mixture ratio, exact air fuel ratio by the stoichiometric ratio. So if this when this air fuel equivalence ratio is near about 1, that means the ratio the fuel is using the stoichiometric ratios air fuel mixture. So the in rich mixture NOx producing are decreased, and for the lean mixture the NOx producing is increasing, and in hydrocarbon or carbon monoxide, the emission of hydrocarbon and carbon monoxide increasing with the increasing with the using of rich air fuel mixture. And a rich mixture does not have enough oxygen to react with all the carbon and the hydrogen, and both hydrocarbon and carbon monoxide
emissions are increasing. For equivalence ratio less than 0.8, hydrocarbon emission also increase. Hydrocarbon emission also increase for less than 1, the hydrocarbon emissions also decrease. For the equivalence ratio less than 0.1, the hydrocarbon emissions also decreasing. But after the 0.8 of equivalence ratio, the hydrocarbon emissions are increasing rapidly. In the next figure, you can see the NOx, hydrocarbon and carbon monoxide concentration with the air fuel equivalence ratio. So in case of carbon monoxide, the the concentration is almost constant with the air fuel equivalence ratio, but NOx is increasing rapidly, and in case of hydrocarbon, sometimes decreasing, sometimes constant, and after that, the increasing of concentration of in the change of equivalence ratio. For a four-stroke diesel engine, the hydrocarbon, carbon monoxide, and NOx emissions are decreased slightly with the increase of equivalence ratio, and it is due to higher cylinder temperatures that taking it easy to burn any other kind of mixture, or lean mixture, or rich mixture, or any kind of fuel mixture at high load. However, hydrocarbons may be increased gain if the amount of fuel is too much high to burn during the primary combustion process, and carbon monoxide emissions will be very low. Carbon monoxide emissions will be very low at all equivalence ratio, and NOx emissions will increase. You can see the NOx emission, as I told earlier. You can see the NOx emissions are increased with the equivalence ratio, but up to the 0.8 or 0.9 shown here, means the lean mixture. Okay, today I am completing this lecture with this engine emission basics. Next class I am talking about the hydrocarbon emissions. What are the causes of hydrocarbon emissions? What are the causes of incomplete combustion? As I told you today, the incomplete combustion means it generates huge amount of hydrocarbon emissions. So incomplete combustion or the non-exhaust combustion, non-exhaust emissions are the very drawback of an automobile to for our environment. Okay, okay, thank you.